Hi viewers, welcome back. So we have a question here to solve today, and from all look it is an indices expression and we are told to simplify it. So without not wasting much time, we will go into solving it, but I'm going to take it step by step. So for those who don't know much about the rules and how it is being applied, I will show you the rules and their application when solving it. So stay tight as we solve together. All right, so solution. Looking at this, we have some index and all bracketed with some powers outside. So all these are powers, and there is a rule that simply states that a power can multiply a power outside, which is the rules of power. I will write the rule here then and I will clean it up. It says that when you have an indices of this format, a raised to power m into brackets n. Now it is the same thing as a raised to power m times n. So this is what we will use to expand this bracket first. So let's start. I'll be taking these brackets one after the other. So expanding this, remember that these two, which is a coefficient here, have the power of 1. So therefore 1 times 1 will be what? 1 over 2. So therefore I have 2 1 over I have 2 1 over 2 dots. Now 3 times 1 is 3 over 2. So I will have x 3 over 2 dots. This dot here means multiplication. Minus 4 times 1 is minus 4 over 2. So I will have y minus 4 over 2. And minus 4 over 2, now you have minus 4 over 2. It's still the same thing as 2 here 1, 2 into 4 is what? 2, which is minus 2. So this is the same thing as minus 2. So we now have a multiplication. The same thing occurs here. This has a power of 1. So 1 times 3 is what? 3. 3 divided by 2 is 2. So therefore I'm having 4 raised to the power 3 over 2 dots. Now minus 2 times 3 is minus 6. Minus 6 divided by 2. Minus 6 divided by 2 is minus 3. So therefore my x will be raised to the power of minus 3. Now the same thing occurs here for y dots. Y. 3 times 3 is what? 9. 9 over 2. When you cancel it, you have a fraction. So therefore I will write 9 over 2. I'll repeat the same protocol for my denominator. I introduce the 1. 1 times 1 is what? 1. So this will be 8 raised to 1 over 3 dots. The same thing here. X. 2 times 1 is what? 2. 2 over what? 3 dots. Y here, the same thing. There is a 1. 1 times 1 is 1. 1 over 3. So we have been able to remove the brackets. So I think at this point again now is to simplify further. All right. Now simplifying further, we will simply change this into a root or a sort form. Now there is a law that states that a raised to power m over n, that is when a base is raised to a fraction, it can simply be written in the form of a root, where the base will be in, the denominator of the numerator of the fraction will be raised to it, and then the denominator will be out, depending on what it is. So using this method here now, we will use it to change these our constants that are in a fractional form. So let's take note of it as we are working, because we are simplifying further. Okay, so we will now have this. My base will come into the roots form. My numerator, which is 1, will be written here, and my 2 here. Dots. I have my x raised to power 3 over 2. And I want to collect like terms together at once. So therefore, I will bring this dots. Here is my x. X raised to power minus 3. Alright. Times. Now this 4 raised to power 3 over 2. We'll also repeat the same thing we did here to it. So I will have my roots. Now my base will be in. The numerator will be on top. And then the denominator will be here. So these two here indicate that this is the square root. These two here also indicate that this is the square root. Okay, so I have my dot y raised to power and minus 2 dot y raised to power 9 over 2. Remember, mathematics is commutative. Anyhow you arrange it, you still get the same answer. Okay, so I've sorted this out. The same thing also I'll do to my base here. Now 8 into this. So 8 into this will be 8, 1, 3 dot x raised 2 over 3 dot y raised to power 3. So these are the essential steps first to take note of. All right, so we have been able to simplify it to this level. I believe you're all understanding the steps. Now, remember I said that this is just the same thing as square root, so it does not matter the two here. I was just putting it here so you understand how it came to be. Okay, so this is what? The same thing as the root of 2. So I'll have it down here, root 2. Now, dot. Now, we are having x times x. Remember, this dot is representing x. So, let me just put it root 2x. Now, one of the rules again in the indices states that when the base are the same, that is s times x, a raised to power m times a raised to power n. You just take a and then m plus n. So this is what that rule states. We are going to apply the rule now. So therefore, this is s times x. We take one s and we add up the power. The power here is what? 3 raised to power 3 over 2 minus 3. Okay, so we also have a multiplication at the other side here. Now guys, what is 4 raised to power 3? 4 raised to power 3 is 64. What is the square root of 64? The square root of 64 is 8. This is what I did here. 4 times 4 times 4 is 64. The square root of 64 is 8. Now, both are having y. I will take one y and sum up their power, which is minus 2 plus 9 over 2. Okay? I move further again. Now, this is the cube root of 8. What is the cube root of 8? The cube root of 8 is 2, because 2 times 2 times 2 will give you 8. So therefore, I'll write 2 here, multiply by, their base are not the same, so I cannot sum up the power. I will still write everything the way it is. S raised to power 2 over 3. S raised to power 2 over 3 times y raised to power 1 over 3. Okay, so we simplify further. We have our root 2. And we have our root 2. And we have x. Now taking LCM, if I should put 1 here over 1 and take the LCM, the LCM of 2 and 1 is what? 2. 2 into 2 is 1. 1 times 3 is 3. Minus 1 into 2 is 2. 2 times 3 is what? 6. So 3 minus 6 is what? Minus 3 over 2. So we are left with minus 3 over 2. Multiply. Here we have our 8. So we also do the same thing here. LCM. The LCM of 1 and 2 is 2. 1 into 2 is 2. 2 times 2 is what? Minus 4. 2 into 2 is what? 1. 1 times 9 is what? 9. So plus 9. So what's minus 4 plus 9, guys? Minus 4 plus 9 is 5. So, sorry, this will be y raised to power 5 over 2. Okay, so all over 2 times x raised to power 2 over 3 times y 1 over 3. There are shortcuts to follow in doing this, but I'm just explaining everything step by step so that you will know it and then later you will now see how to apply the shortcuts in getting the answers. All right. So in this situation now, I can take out my coefficients aside. So my coefficient here will be 8 root 2, because 8 times root 2 will be 8 root 2. Like writing very close to each other because I'm trying to minimize this. 8 root 2. Now we are left with what? X raised to power minus 3 over 2 times y raised to power 5 over 2. No, correct. Yes. So, all right, divided by 2 times s raised to power 2 over 3 times y raised to power 1 over 3. Okay, this will take us to another rule again. Now, it will take us to the division rule. When the base are the same, you take one of the base and then you subtract the power. That is what division rule talks about. So here now simply 2 can cancel out here 1, 2 can cancel out 8 here, we have 4. So we are left with 4 root 2 here. So now let's do the same thing that we just see there. We have x minus 3 over 2 divided by x 2 over 3. So we will represent it here again in the fractional form using this law here. So I'll go further to say x minus 3 over 2. Now, minus 2 over 3 times y 5 over 2 minus 1 over 3. That is it. Okay. So simplifying this thing further, what's our LCM here? Our LCM here is what? 6. 2 will enter 6 how many times 3? 3 times 3 will give you minus 9. 3 will go into 6 how many times? 2. 2 times 2 will give you 4. So minus 9 here will be 4. So we are left with, remember we have 4 root 2 here already. So we have 4 root 2 already. Minus 9 minus 4 is x into minus 9 minus 4 is minus 13 over 6 times y. Now what's the LCM here? The LCM here is okay 6. 2 into 6 is what? 3. 3 times 5 is 2 into 6 is 3. 3 times 5 is 15 minus 3 into 6 is what? 2. 2 times 1 is what? 2. So 15 minus 2 is what? 13 over 6. Nice. So therefore y will be 13 over 6, the positive one. Okay. So in this scenario, we are already close to our answer. We can leave it in this system, or we will still return it to a fractional way so it will look presentable. So guys, this is what we have here now. So remember another rule again in indices. I'm just using these questions to show you all the rules in indices. One of the rules again is the negative rule. And the negative rule states that a raised to power minus n is the same thing as 1 all over a raised to power n. So here now that we have x raised to power minus 13 over 6, we will change it into this format and present our answer. So this will become 4 root 2 times 1 over, what's our x now? It will now become what? X raised to power 13 over 3. 13 over 6, sorry, times y raised to power 13 over 6. So in this scenario, we'll have 4 whole number root 2. 1 times this will be the same thing as y 13 over 6 all over x 13 over 6. And this is the final answer to the question. All right, thank you guys. So I believe have been able to understand more than 4 or 5 rules of indices and how it is being applied in solving questions. See you in the next video. Bye for now.